Okay, welcome. This video is part 2 of a lab experiment where our goal is to determine the equilibrium constant of this reaction right here. So we're reacting iron ions and thiocyanate ions to make iron thiocyanate. And a key thing with this reaction is that the two reactants we're mixing together are clear, and the product of this reaction is not. It is this kind of red substance. This is what it looks like. You can see some examples right here of that reddish color. And the more concentrated the iron thiocyanate is, the darker the solution is going to be. So in part 1 of this experiment, what we did is we made some solutions with known concentrations of iron thiocyanate, and we graphed that. So we measured concentration versus absorbance. This is commonly known as a Beer's law plot. So tells us the relationship between concentration and absorbance, and we found the slope of this line, and in these conditions, the slope of the line is 2,410. Okay, so now what we're going to do is we are going to try and use this information to find the equilibrium constant. So what we're going to do is in these test tubes right here, I'm going to mix together some iron and some thiocyanate. So here is some iron. And it doesn't really matter how much we use, but we just want to carefully record how much we do decide to use. So for solution A, I'm going to take 4 milliliters of this iron solution, and the concentration of iron is 0.00280. Okay, and this is iron nitrate, so it's the iron ion with a +3 charge. Notice how it is clear. And I'm going to use this right here. This is a volumetric pipette. This is a nice, accurate piece of glassware to use for measuring out volumes here. And the way that the volumetric pipette is, you use this pipette filler up here, and what we do is we kind of dial it up like this, and you may not be able to see this very well, but the liquid is moving up the pipette, and what you want to do is you want to fill this up to 0. Okay, so now it's at 0. And 0 does not mean that there's 0 milliliters of liquid in here. It just means that this is calibrated to deliver. So that means I have delivered 0 milliliters of volume. So right now I've just kind of filled it up to its starting point. And now if I want to add 4 milliliters of this solution to this test tube right here, I'm going to go over here and I'm going to now dial it the other way. And I'm going to carefully dial it down until I stop exactly at the 4. And we want to read from the bottom of the meniscus. So I have now added exactly 4 milliliters to my test tube there. All right, and I'm going to put this solution aside. So this is my 4 milliliters of iron. And then I'm going to do my thiocyanate now. And I'm going to add 6 milliliters of thiocyanate. So I'm going to add the pipette filler, and then right here you can see that, and then I'm going to dial it up until I have this pipette filled up to 0. Whoops, I need to start over here. Sometimes we can start over. Okay, I'm going to reattach this. Okay, so I'm going to dial this up until it reaches a 0. And then I think I said I wanted 6 milliliters. So I want these solutions to add up to 10. That just makes my math easier later on. All right, so I added 4 milliliters of the iron, and I'm going to add 6 milliliters of the thiocyanate. So I'm going to go over here, and if you watch while I add it, you should see the solution turn red when these two clear substances mixed together. You can see the color changing. So we're going to add exactly 6 milliliters. Okay. And we are trying to find the equilibrium constant. And so what that means is no matter what combination of reactants we use, we should be able to use like 3 mils and 7 mils, or 5 and 5, or 4 and 6, or any combination of volumes should give us the same equilibrium constant at the end. So ideally, we would have several different trials and everyone in the classroom would try different, combinations of volumes, and we should all end up with an equilibrium constant that's about the same. We're just going to end up doing 2 mixtures, so we'll do one that is 4 and 6, and I'm going to pause the video and make another solution that's another mixture, and we'll just use 2 data sets here. Okay, so I have now made these 2 solutions, solution A and solution B, and I will put this up here so we are clear on how I made these. So for this one, I had 4 mils of the 0.0028 molar iron and 6 mils of the 0.0021 molar SCN. And then over here, I used 5 and 5. So we just have 2 different solutions here. We can see they're both a reddish color, so that indicates that we've made some iron thiocyanate. That's the product of this reaction. And what we're going to do next is we are going to use these pipettes to place some of this solution into this cuvette, and then we are going to place it over here into our little spectrophotometer, measure the absorbance, and then once we have the absorbance of this solution, that's where we're going to go back to this set of data. And if we know the absorbance of our solutions we just made, we can plug that into this equation and solve for the concentration of iron thiocyanate, which remember is our products. Okay. So again, to summarize, what we're going to do is we made some solutions, and we're going to have to do a little bit of a dilution calculation to figure out what our actual starting concentrations are. Because notice how we started out with 0.0028 molar iron, but we actually mixed it with something else. So this concentration is actually going to be lower than 0.0028. So we're going to have to do a little M1V1 calculation to figure out what these starting concentrations are, because these all got diluted when we mixed them together. Okay, and we mixed them together, they formed iron thiocyanate, which is red. That's this stuff right here that we see that's red. And we're going to use the absorbance to figure out what the concentration is of that iron thiocyanate that we made. And then once we have all that information, we should then be able to calculate what the equilibrium constant is for this reaction, because we'll know the initial amounts of our reactants, and we'll know how much the final amount of our product, so how much product we have at equilibrium, and we'll be able to take all that information to calculate and find the equilibrium constant. All right, so I'm going to switch views, and I will show you what the absorbance readings are for these 2. Now we are going to measure the absorbance of these 2 solutions. So you see right now the readout here from the spectrophotometer, and I'm placing solution A in right now. And there is a readout down here on the bottom left. So it looks like the absorbance for mixture A is 0.600, 0.599. It seems like it's fluctuating by 0.002. So, and I should also say the absorbance values are unitless. So if you're wondering what's the unit of absorbance, there is none. It's just 0.600, 0.597, maybe you want to say here. Okay. And now let's take this absorbance reading for solution B. I'll pop that one in there. So the absorbance for solution B is 0.570. Again, that's a unitless value. And then now we have all the information that we need to complete this.